Welcome to ProKitchen University, an online video tutorial series, version 11.06. Welcome to the Cathedral Ceilings Part 4 video tutorial, Ceiling Beams. This video is a complete demonstration on how to add flat and angled ceiling beams to a cathedral room. In the first two videos of this tutorial series, we learned how to create the cathedral ceiling shapes and how to add skylight windows. In this video, we are going to explore how to add decorative ceiling beams to these cathedral rooms. First, let's set the cathedral shape for this room. Access attributes from the wall that will hold the peak points of the cathedral shape. Select the Cathedral tab on the left. Then select the desired cathedral shape and proceed with adjusting the cathedral parameters. For this demonstration, I will create a gambrel cathedral ceiling. The left vault position from the left end of the room will sit at 39.5 inches. I want the left vault height to sit at 0 inches from the foundation wall. This will create a space of a flat planar ceiling along the left end of the room. The center vault position will remain at the center of the wall, with a vault height at an additional 24 inches above the foundation wall height. And the right vault position, from the left end of the wall, at 221 inches, with a vault height once again at 0 inches to create a mirrored flat ceiling along the right end of the room. Before moving forward, it is important to make a note of the cathedral ceiling parameters, as we will need to reference them later in this process. Once the parameters have been set and your notation taken, left-click OK to create the cathedral ceiling. Now that the cathedral ceiling has been created, let's create an elevation view. Either right-click on the wall, head to the wall number, into the toolbox, and select Inside Elevation, or left-click the wall once, then select the elevation icon on the toolbar. Let's briefly explore creating a straight ceiling beam and place one at the interior edge of both flat sections of the ceiling. Ceiling beams do not have comparable items from any of the sample catalogs, so we will need a user shape to create this design element. Navigate to either the doors or windows icon on the toolbar and left-click to launch a dialog box. Select the User Shapes folder. Making your selection here will depend entirely on a couple of factors. First, how will this item move? Floor user shapes can move anywhere within the space and may be moved in all directions: left, right, up, down, and in, out. Wall user shapes can only move in two directions: left, right, and up, down, and will always have the back of the item attached to the face of a wall. The second factor to consider is, on which axis will I need to make my edits? Floor user shapes can only be edited on the horizontal axis from the plan view, while wall user shapes may only be edited on the vertical axis from the elevation view. Since we do not intend on making any edits, and the desired placement is with the back of the item sitting against the wall, for the standard horizontal ceiling beams, we may either use a floor user shape or a wall user shape. For this demonstration, I will use a wall user shape. Once selected, click the Place button and left-click once to drop it in the elevation view of the cathedral wall, and left-click once more to secure. When the dialog box reappears, left-click Cancel. User shapes, by default, will be a 24 by 24 half-inch thick piece of auburn wood. To alter this item into the 6 by 4 beam that runs the entire depth of the room, access Attributes with either the right-click menu or with a double left-click. In the Attributes dialog box, in the General tab, We may now make the appropriate dimension changes. Width is the left-right dimension of the item along the face of the wall. I will enter 6 inches in this field. Height will reflect the vertical dimension and will be set at 4 inches. Depth is the distance from the back of the item into the room, and I will enter the same value as the interior wall length that will run parallel to the item. Next, we will want to adjust the texture. Click the Texture tab to open. For this demonstration, I will select Non-Wood, so I may use any of the installed or imported textures. Then move the mouse over and down to click the Select button. The Textures dialog box will appear, and you may either enter the sample name, number, or keyword in the search field at the upper left, or navigate the catalog tree. Left-click the desired texture sample to select. Rotate the sample to reflect the horizontal grain along the beam. And you may want to click the Favorites button to save the texture for easy access later on. Then click the OK button. Once both the dimensions and the texture have been altered, click the OK button in the Attributes dialog box to apply. Now we need to maneuver this user shape into the appropriate placement. Let's first move it up-down to sit flush with the ceiling. This will be most easily done in the elevation view. Select the user shape with a left click, and either drag it up the height of the wall to sit flush with the ceiling, then left-click to secure, or use the top or bottom fields now displayed below. The top field represents the top of the item in relation to the top of the wall, and should be entered as 0. The bottom field represents the bottom of the item in relation to the floor, and should be entered as a positive value, reflective of the height of the wall minus the height of the user shape. Once the value has been entered, tap the Enter key on the keyboard. Moving this item left-right will be most easily done from the plan view. Hover the mouse over the user shape here, and left-click once to activate left, center, and right dimension fields below. This is where we need to do just a touch of math. We created the ceiling shape so the left edge is a flat planar ceiling to span the distance of 39.5 inches. We created the user shape to be 6 inches wide. So 39.5 minus 6 is 33.5 inches from the left end of the wall. Activate the left field, type the correct value, and tap Enter on the keyboard to move and secure. To create an identical beam for the right end of the room, we may simply right-click the user shape and select Copy from the toolbox. Then left-click in the elevation view to place, and click a second time to secure. Then repeat the relocation process, this time with the 33.5-inch value entered in the right field. Now that we have a couple horizontal beams, let's work on creating the angled beams to sit parallel to the slope of the cathedral rise. This time we have to utilize a wall user shape since we will need to do some editing on the vertical axis. Navigate to the doors or windows icon and left-click to launch. Open the User Shapes folder and select the wall user shape. Then click Place. Drop this item in the elevation view and click Cancel in the dialog box when it reappears. Now let's start the process of turning this into an angled ceiling beam. Head to Attributes as previously demonstrated. In the Width field, we will need to enter the left-right dimension at a value that is approximately half of the remaining distance between the beams we previously created. This value does not need to be perfect, since we will be using the Edit tools to span the distance and create the angle. The height value will remain the same as that of our previously created beam, at 4 inches. Depth, this time, will reflect the 6-inch width of the beam, since the width of the beam will reflect the distance from the face of the wall into the space. Head to the Textures tab, select Non-Wood, and click the Select button. If you previously saved the texture, You may select it from the Favorites panel at the upper right of the dialog box. If not, use the search field or the catalog tree to locate the texture sample. Remember to rotate the sample to the horizontal orientation, then left-click the OK button to apply, and click OK in the Attributes dialog box to create the beam. Let's move this to an appropriate location to work from. Left-click the wall user shape in the elevation view, and move this so it sits at 0 inches from the top of the foundation wall. Then left-click the wall user shape in the plan view, and move it to sit directly at the left edge of the existing beam, which will be 33.5 inches, plus 6 inches for the width of the existing beam, at 39.5 inches from the left end of the wall. To get started on the angle of the beam, in the elevation view, right-click the wall user shape and select Rotate from the toolbox. Then move the mouse to rotate the user shape. You may want to zoom in so that you can see when the top edge of the user shape is aligned with the angle of the cathedral slope. Once satisfied with the angle of rotation, left-click to secure. Now to alter the ends so that they appear as the 45-degree miter cuts. For this, we will need to utilize the User Shape Edit tools. Right-click the user shape, slide into the toolbox, and select Edit. This will turn the outline of the user shape red and populate open points at each corner. For this process, we will focus on the corner points. Starting at the bottom left point, left-click the point once to grab. Then move the mouse down and over to meet the bottom right corner of the previously placed user shape and left-click to secure. At the right end of the user shape, we may need to move both end points. One to sit at the top of the cathedral rise, and the lower point to sit so the edge is vertical in orientation. Left-click the uppermost point once, then move the point so it sits at the cathedral peak, and the top edge is in alignment with the angle of the slope. Then left-click to secure. Next, hover to the lower point, left-click once, then move the mouse so the point sits below the cathedral peak, doing your best to maintain a consistent angle. When the edge displays as vertical, left-click again to secure. Once you are satisfied with the shape, tap the Escape key to release the Edit tool. We will need a second angled beam for the downward slope of the cathedral ceiling. You may create a secondary beam by walking through the process again, or we may copy this one as previously demonstrated, and then make a few adjustments. For this demonstration, I will right-click and select Copy, then left-click in the elevation view to drop it. This needs to be a mirrored version of the original. So once again, right-click to open the menu and select Rotate. Then move the mouse to rotate the beam into the approximate slope of the rise that we intend to match, and left-click once more to secure. Currently, it isn't quite perfect and will need to be rotated again, but this will be much easier to see once we move the right top corner to sit next to the existing beam on the right. We can do this manually with a left-click and hold, or by moving the item with the up-down and left-right movements as previously demonstrated. Once the right end top corner is sitting at the top left corner of the existing beam, we may rotate once again to match the rise of the slope. Access and use the Edit tools again to make adjustments to the 45-degree mitered ends so that both ends of the user shape match up to the existing item's vertical edges as previously demonstrated. Now we may open the elevation view of the south wall, so we may copy and paste the two beams we just created into place. And of course, make minor necessary adjustments of the rotation and mitered end edits to finish the angled ceiling beams at the south end of the room. Fantastic! Now we have angled ceiling beams at both the north and south ends of the room. But frequently, when there are angled ceiling beams used as decorative features in a room, we will see them placed along the interior depth of the space. Knowing we need to use wall user shapes to create these features, and that wall user shapes need a wall face to be adhered to, we will need to have additional walls that run horizontally along our room. Using a standard wall, however, would disrupt the visuals and create individual interior rooms. So in order to avoid this circumstance, we will need to create the wall faces with a construction line, which is a zero-width invisible wall. Navigate to the C-line tool found in the Draw and Place ribbon, and left-click once. Then move the mouse into the plan view, away from the design. We will move this into place a little bit later. Then left-click once to drop the construction line. Move the mouse in the same direction as the north wall was drawn, and utilize the length field now displayed below to enter the same length value as the north and south walls, and tap Enter on the keyboard to draw the construction line. Then tap the Escape key to release the tool. Before we move this into place, we will want to make sure that this has the same cathedral shape as we created before. Navigate to Attributes, select the Cathedral tab on the left, and reconstruct the exact same cathedral shape, referencing the notations we took down at the beginning of this process. When the appropriate parameters have been entered, left-click OK to apply. To move this into the room, left-click the construction line in the plan view to activate the wall handles. Left-click once on the wall handle that sits on the center of the C-line to grab. Then move the construction line into the room and place it so it sits perfectly in the interior of the room. Then left-click to secure. This process will need to be done for each additional set of angled ceiling beams the design requires. For this demonstration, I will create and add 2 additional construction lines so that I have 3 in total. Before we create elevation views, copy and paste, and make final edits, I will want to make sure these construction lines are spaced in such a way that the empty space between the beams are equal. Time to do a little math. I have a room at 282 inches in depth, minus the 6-inch depth of the south ceiling beam, which will reflect a face-to-face placement of beams in the 4th section, instead of face-to-back placement in the other 3 sections. Divided by the 4 sections of the room created by the construction lines, equals 69 inches of required space between the north wall and the first construction line, and each consecutive space between the remaining construction lines. Note, the bottom section will have 75 inches of space between the construction line and the wall, but does not account for the 6-inch depth of the existing ceiling beam. To do this easily, we will utilize one of the dynamic dimension tools to assist us in this process. Navigate to the Measurements and Comments tab and left-click the L to L icon. Move the mouse into the plan view and place the mouse at the face of the stationary wall. When the purple line displays, left-click once to start the measurement. Then drag the mouse to the construction line that needs to be moved. And when the purple line displays, left-click once more to create the dimension line. Repeat this process for each consecutive construction line, remembering to start on the previous construction line and ending on the next one. To move each of these into their appropriate position, left-click the first created dimension line to select. It will become outlined in red, and now, at the bottom of the ProKitchen window, the length field will be displayed. Enter the calculated value, then tap Enter on the keyboard. Repeat this process until all the construction lines are in the preferred placement. From here, we may create the inside elevation view for each of the construction lines. Copy and paste the wall user shapes we created previously into the elevation views, and make any necessary rotational or editing alterations. From here, we could add additional horizontal cross beams using floor or wall user shapes, or vertically placed supportive ridge beams with wall user shapes, using the edit functions to create the desired shape in order to complete the finished look. With ProKitchen software's capabilities, you can create the truest to final product renders. With the cathedral ceiling options, you can take your designs from flat to dynamically elevated, apply skylight windows to add radiant illumination, and utilize user shapes and construction lines to create decorative ceiling beams that will provide an impressive and breathtaking finish for cathedral ceiling rooms. Thank you for visiting ProKitchen University. Be sure to visit us at prokitchensoftware.com.